Okay, so we're going to go ahead and pick up again with two equations, solving for two unknowns. We've done our equilibrium, we've done intercepts, we've created a graphic. You might notice as we're coming back from a brief break that I've changed the supply and demand equations, primarily because I didn't like that we ended up with a negative solution. And even though we can understand it, it's harder to go through some of the rest of the elements I want to talk about. So let's talk about tables of values, and then we'll discuss how we use tables versus equations, and then let's hit elasticity, and then we'll go ahead and look at friction, and we'll look at both those hard. So a table of values. I know that I'm going to end up with some W, some labor supply, and some labor demand. And if I know one of these numbers for any given row, I can find the others. If I know labor supply, I can go to the labor supply equation. Let's say labor supply is 20. I can say 20 is equal to negative 10 plus 3W. So 20 is equal to negative 10 plus 3W, or 30 is equal to 3W, or W is equal to 10. So if I know that this was 20, I now know that this is 10, right? And if my W is 10, I can now put it into the demand equation. 15 minus 2 times 10, 15 minus 20, so labor demand at that is negative 5. So I must know one of the three variables in any given row, and it will then let me know the others. Typically, you're going to have some knowledge of W. And the reason for that is because firms in competitive markets, and the first half of this class is primarily about competitive markets, firms are wage takers. They don't create or affect the wage, so wage is considered exogenous. It comes from outside, external to the system, so we think of it as given. Excuse me. So let's just kind of look at what we've got here. Let's assume we go from a wage of 0 to 5. Now let's not use 5. Let's go ahead and move it by 2 each time. 2, 4, 6, 8, and 10. Okay? And we're going to use the labor supply equation to find the labor supply values. So if labor supply is equal to negative 10 plus 3 times W, negative 10 plus 3 times 0 is negative 10. Negative 10 plus 3 times 2 is going to be negative 4. Negative 10 plus 3 times 4, 3 times 4 is 12, so now we are at positive territory finally, right? Negative 10 plus 3 times 6, so 18, so I think we're at 8. Notice what's appearing before us. If we have a change in wage of 2, we know we have a change, an upward change in labor of 6. Change in 2, upwards of 6. Change in 2, upwards of 6. If I want to, given that I know that this is a consistent change, I don't even need to continue calculating. I just know it's going to change by 6 each time. They're going to look something like that. Okay? Well, let's look at demand. So labor demand, 15 minus 2W. When W is 0, 15 minus 2 times 0, or 15. 15 minus 2 times 2, or 11. And once again, I can keep doing my calculations, or I can recognize as this changes by 2, this changes by 4, which shouldn't surprise me because that's the scalar in our right-hand variable. So I should go down by 4 each time, and I now have my table. Well, can I see from this table expressly where my equilibrium is? I can't, can I? There is no one wage at which supply and demand have the exact same number. So how do I think about this? How do I determine equilibrium in this case?
You find the middle ground?
Maybe. I mean, I can kind of visualize it. You know, I'm here. Negative 4 is less than 11, 2 is less than 7, 8 is more than 3. So somewhere in here, I don't want to be bold enough to say exactly where here, in between here it is, because I'm making the supposition when I do that, that I've got a linear relationship, which in fact I happen to in this case, but sometimes I don't. So I like the table of values just because they let me see some things, but honestly I rarely use them. I rely on the equations themselves. So let's use these two equations, which again are different than the ones we used earlier. Let's quickly find the way that this looks, and then we're going to talk about elasticity. The x-axis is always some unit denominated variable, in this case labor. The y-axis is always some currency denominated variable, in this case it's wage. And wage may be dollars per hour, wage may be dollars per month of actual income on a paycheck, or it might be income on a paycheck plus benefits plus vacation per week. So it's the total wage bill. Always look at the question to see how wage and or labor is defined. If you see the labor is defined as a number of workers times 100, then W and L stars don't change. They are the byproduct of the equation, but when we interpret them, then that changes. And so we'll think about that in just a moment. Well, what I'm pretty sure of is that I've got a demand curve that is going to look like this somewhere. I know I can go through and find my intercepts. I can set wage equal to 0, in which case LD is 15. I can set LD equal to 0, in which case I have 2, W is equal to 15, or W is equal to 7.5. One of the things I know is that if the constant in my labor supply equation is negative, and it's a linear relationship like this, this is going to cross the y-axis in lots of space. Just kind of a little cheat item, if you will. If this is positive, it's going to cross the y-axis in negative space. So it's negative, so we know it's going to cross in positive. So I know when we've got LS is equal to negative 10 plus 3 times W, it's going to be out here at negative 10. And when 0 is equal to negative 10 plus 3W, then 3W is equal to 10, or W is equal to 3 1/3. So 3 1/3. And we know that it's coming up like this and continuing on. There's no bounds of those relationships, they keep going, right? We're typically not interested in what's happening in negative space, but as we saw a few minutes ago, maybe we are. Maybe our curves tell us about something in negative space. It's just a little unusual. So that's what this is going to look like. I might have been able to take these LS and LDs and these wages, and I might have plotted some things out, and I could have found these, right? But I had a hard time with some of these, and I wouldn't know exactly what this point is. I need to know exactly what that point is. So even though sometimes when we're not comfortable equilibrating LS and LD, we'll rely on the table, I'm going to ask you to not do that, because it's a crude measure at best, and it's reliant upon you having perfect proportionality in your graphics down to the nth, which is hard to do, and frankly, I tell you to even bother with it. So, negative 10, as I go to LS, it equals LD. Negative 10 plus 3W is equal to 15 minus 2W, or 5W is equal to 25. W star is equal to 5. Well, I like that number. And now I can take that 5 and put it back into either of these equations and find my L star. So 15 minus 2 times 5, 15 minus 10 is 5. Okay. What about negative 10 plus 3 times 5? Negative 10 plus 15 is also 5. I haven't screwed it up. And once you've done this more than once or twice, you know how to do it well. You don't have to do both of them. I just like to at least once do that to make sure I know I haven't screwed up. So what I'm looking at here then is W star at 5 and L star at 5. That makes sense to me. 7.5 is greater than 5 is greater than 3 1/3. 15 is greater than 5 is greater than 0. So it visually lines up with my expectation, and fortunately it's in positive space. Okay? If this was $5 an hour, and if the workers, if L equaled if W equals dollars per hour, and L equals 10,000s of workers, now we're looking at $5 an hour and 50,000 workers. So this is probably a very low-skilled relationship, right? It appears to be because of the outcome to us. So let's say for a moment this is a market of low-skilled workers. It's indicative to us of some of what we see about it. Knowing what we know about minimum wage, though, is it a market that's legitimate? Well, what's minimum wage today across the country at the worst?
$7.25.
Yeah, I think that's the lowest we see across the country. And I think that's still the federal minimum wage. That's changing soon. Over the next several years, most minimum wages in most states and the federal level will bump up through 15 and keep going. So if it's $5 an hour, this is not a formal market, is it? Well, but it might be a realistic market. Claire, do you know what the going wage is for low-skilled manual laborers in this valley?
Too low?
Okay, agreed, too low. Okay, any of us have ever done manual labor? I have. You guys might have. Too low. I know exactly what it is because I can get my pickup truck on any given Saturday morning. I can drive to the corner of the parking lot at Home Depot at 21st South, and there's any number of able-bodied individuals, men and women, a variety of ages, that are happy to hop in the back of my pickup truck if I'll give them $5 or $6 an hour. So this is not unrealistic for the informal market, but it might point out to us why we have a minimum wage. So what I'd like to do, if you're okay with this, Dom, is move to friction before going to elasticity. Okay, because we're kind of setting it up here, may as well look at it. So friction helps us understand some changes in surplus because of some imposed wage level or labor level. So we'll look at a couple of them for a moment. And we'll use these equations, everything we've got going on the board so far. So let's assume that this is a market where the market clearing perfectly competitive wage was $5 an hour. And there's plenty of workers, 50,000 of them in this particular market, so low skilled. And somebody comes along and says, you know, that's a problem, that's not societally optimal, let's impose a minimum wage. Well, a minimum wage is a wage floor or a wage ceiling? What do you think?
It's a wage floor.
Okay. I think it's a wage floor, which is going to look a little counterintuitive because it's above W star. And we think of floors as being below us, but you have to think of a floor as something we don't go below. It's not that it's not below us, it's we don't go below it, okay? So in this case, we've got a minimum wage, let's say at, we're going to call it 7 1/4, such that we know it's going to set up some mismatch. We just know that's going to happen, such that we're going to have a labor demand that's going to be less than our labor supply. And when demand is less than supply, we have a surplus of workers, and we call that unemployment. If demand was greater than supply, then we'd have a shortage of workers, and then maybe some black market would arise to deal with that. So something outside of a legitimate system. Let me move for a moment this 5, make it smaller so it's not quite as in the way for us. We'll just say over here equals 5. Well, that's fine. We knew that was going to happen. Let's think about surpluses before this went into effect, and then let's think about surpluses afterwards. So I'm going to go ahead and get rid of a few of these lines just so I can do this more easily, or without confusion, let's say. And I want to think about worker surplus and employer surplus. So think about this. If you know consumer economics, you know producer surplus and consumer surplus, right? And consumer surplus is above P star, below QD, and bounded by Q star. But I'm saying that employer surplus, not consumer, is above W star. That's a little confusing to us until we stop to think about who consumes labor. Employers do. Well, this is consumer surplus. It's just that the employer is now the consumer rather than producer. So you have to think about it like that. And who produces labor? Workers. Okay? Well, what do either of these mean? Worker surplus tells us that since we're required, because of the market conditions, the competitive market condition, to pay 5, that this worker down here, this one single solitary worker, has a supply relationship that would have caused them to work for a little bit above 3 1/3. So if the market condition is giving them 5, the difference between 5 and 3 1/3, or a little bit above it, is some surplus for them. And we can then see that happen all the way along, such that worker surplus is the area under W star, or whatever our wage happens to be, above labor supply, bounded by whatever our L is. In this case, it's L star. So, Claire, how do we calculate that? Any idea?
Do the area of the rectangle from 0 to 5, and then 0 to 5 for the 0 to 5 for the wage, and then up to 5 again.
Yeah, so we're going to think of this. We're going to think of each of these as a triangle, right?
Right.
So we first have to find the rectangular base and height, and then we're going to divide by 2. Because any triangle we can think of is going to be equal to base times height divided by 2. Well, in this case, if we're looking at employer surplus, we've got the base 5 times the height. Well, in this case, above W star, below, or above W star all the way to labor supply, so 7.5. So we're at 2.5 divided by 2, which I think is, I believe that's 12.5 divided by 2, whoops, 12.5, or 6 1/4. Is that right? 2.5, yep, that's right. So my employer surplus is at 6 1/4. And all that means is the area of this triangle is equal to 6 1/4. And in this case, it's $6.25, right? Or if we're extending it because this is 10,000 of the population, it's $62,500, okay? But we know it's currency related because we're taking some units times some currency. So 5 apples times $1 per apple is still $5. Okay, so it's currency related. Let's think about worker surplus now. So worker surplus, we're still going to have 5 in our base, times, now we've got the difference between 5 and 3 1/3, or I think that's 1 2/3. I'm going to call it 1.67 divided by 2. And since I'm a very simple guy, I'm going to go to my simple calculator. So 1.67 times 5 divided by 2, and it's 4.175. So my worker surplus is a little bit less than my employer surplus. I don't know that that's a problem. It just is what it is. In each case, the workers collectively are getting more than they individually would have been willing to work for. The firms are getting more than they would have individually been willing to settle for. And we call that surplus beneficial to our economy at some level. Such that we have a total surplus that's equal to worker surplus and employer surplus. So equal to 6.25 plus 4.175, or I think that's going to be 10.425, is that right? Let's see if we can cause it to 4.175 plus 6.25, 10.425, I'll be darned. So this labor market that's defined by these equations and represented by that graphic is producing a surplus for this economy, since we have workers in 10,000s, of 104,250, which is not gargantuan and it's not nothing. It's a surplus. They created more because of the efficiency of a competitive market. Okay? Until, of course, we bring into play this exogenous wage, this imposed wage. We agreed that this was a wage floor, even though it's above W star, because we don't want to go below it. So this is something that's been imposed by legislation, politician, contract, whatever it happens to be, and there's been some effort expended to get it there. And we know that it changes the game. We've got now some LD, I'll call it LD prime, and we're going to have some other values we're going to have to think about for a minute. So we can think about now our revised W, our worker surplus, and our revised employer surplus. We'll start with employer surplus first. And we're going to call this ES prime just to differentiate it from our original employer surplus. And now it's going to be the difference between 7.5 and 7.25, or 0.25, times, I don't know this number yet. How do I find this number? Well, I know that if I have a wage at 7.25, I can find its corresponding labor demand by putting it into the labor demand equation. So 15 minus 2 times 7.25, 2 times 7.25 is 14.5. 15 minus 14.5 is 1/2. Okay, so this sits down here at 1/2. So it's not going to be a very big number, right? So 0.5 times 0.25, which I think is going to give us 0.125, divided by 2 is going to give us a smaller number still. What's that going to be? 0.06125? So that's a very small number for employer surplus. But remember, it's times 10,000 workers. Okay? So that's going to make it a little bit different as we interpret this. Let's think about worker surplus now. So worker surplus has changed dramatically. That's employer surplus. Worker surplus has changed dramatically. We now have a much larger area, it appears, but I'm not certain that we do. We know it's different, okay? And I know that I can't just apply the basic triangle geometry to this. I now have to think about how I might apply it, and it looks to me like I can apply this by seeing a rectangle and a small triangle. To do that, I need to find this point. Well, how do I find this point? Well, I know that we've got, on the labor supply relation, some number. I know we've got some wage number. So I want to think about this. How do I find that point? What do we do? Well, I know that point is at an L of 0.5. Even though I've labeled it LD, because where it started from, it is still the same 0.5 here, right? So I'm going to put that 0.5 into my equation such that I'm saying, and it's going to be my supply equation, 0.5 is equal to -10 plus 3W, because I'm trying to find this W, right? Or I can say 10.5 is equal to 3W, or 10.5 divided by 3 is what I'm looking at. .5 divided by 3, so 3.5. And does that make sense to us? Sure, because it is slightly greater than the 3 1/3 that we have there. That makes sense? Okay, so we're okay with that. So now I can find the area of this rectangle, and then I can find the area of this little triangle, and that's going to be my new worker surplus. So the area of the rectangle will be 7.25 minus 3.5, or I think that's 3.75. So remove this. Worker surplus is going to be equal to 3.75 times, well, that's still 0.5, times 0.5, and then plus this tiny difference in the height of this triangle times its base. So that tiny difference is, I believe, 1/6. Is that correct? So 1 divided by 6, so 0.1667. So 0.1667 times 0.5 divided by 2. This will be our triangle, this will be our rectangle, and the sum of them gives us our worker surplus. So what's this add up to? So 3.75 times 0.5, or 1.875, 0.1667 times 0.5 divided by 2. So it's going to be plus 0.04165. We're getting very small numbers, which is why I'm extending the decimals out so far, just to eke out a tiny bit more. So plus 1.875. So it's 1.917. 1.917. We said that was equal to 0.06125. Well, this is not much. In fact, it didn't surprise us that employer surplus was smaller, did it, Don? I apologize, I keep calling you Don instead of Dominic. I hope that's okay. I have a very close friend who's Dominique, and he goes by Don, and that's what I'm referring to. I apologize. You is just going to be clever. Okay. So it doesn't surprise us employer surplus is smaller. We knew it would be just visually. If we had a perfectly proportioned graphic, we would have seen that worker surplus probably was smaller as well. Remember, worker surplus was 4.179 or 175. It's now all the way down to 1.917, so it's more than half, or it's less than half the size that it was. Well, what sits in the middle there is some loss of efficiency to the market as a whole. And we call that loss of efficiency, the area here, we call it deadweight loss. So the definition of deadweight loss is some loss in productive efficiency to the market. And we can easily see it. Employers don't get as much surplus. Workers don't get as much surplus. There's a total surplus, if you will, that's less, and it's less by that area. That's a bit of an issue for us. So what is that number? It's going to be 0.01, it's 0.06125 plus 1.917. So total surplus prime, if you will, is now 3.834. So much less than total surplus used to be at 10.425. And now we have two different ways of thinking about deadweight loss and how we can calculate it. Deadweight loss will be the difference between total surplus in equilibrium and total surplus with this exogenous change. So if that's the case, we can now then say 3.834 minus 10.425, and our deadweight loss, we think, should be equal to approximately 6.59, I believe is the number that I just came up with. Yep. 6.59, and we did that by subtracting the new surplus, the reduced surplus, from the original surplus. Let's see if we can triangulate this and see if we did it correctly. to do so, we want to know the value of this triangle. Well, we've already figured out all of our intercepts. We've got 7 1/4. We've got 3 1/2. We've got 5 minus 0.5. So it's a triangle. So 7 1/4 minus 3 1/2 is 3.75. So this is a new equation for deadweight loss. 3.75. 5 minus 4.5 is 4 1/2. So times 4.5 divided by 2. Let's see if it gives us the number that we think it gives us. 3.75 times 4.5 divided by 2. 8.4375, which is a little bit different. It's quite a bit different than the 6.59 that we came up with. So somewhere with some of our gross roundings, we've made quite a difference here. Or maybe I've made a small error in math at one of these places. As you're looking at the video, you're watching this, you can recreate it and perhaps see where I might have done that. But those are the two ways of finding it. Frankly, I virtually always use this method. And if I think that I may have a problem, then I triangulate it this way. So that's a wage floor, which is a minimum wage. Let's look at a wage ceiling for a moment. We won't calculate it, we just want to visualize it. Okay. Let me get rid of a lot of my hieroglyphics here. This will be challenging. Now we've kind of returned ourselves to the extraordinary artistry that we were already seeing, right? Or, let's face it, anything but. Dominic, where would we see a wage ceiling?
Below W star.
Why would we never see a wage ceiling above W star? You're right, it's going to be below. Why would we never see one above it?
Not sure.
So think about a ceiling. The ceiling is something we probably don't want to go above, right? A little painful when I try to stick my head above the ceiling, okay? I mean, that's kind of a crude way of thinking about it, but it's simple, I think it's the job done. Well, if the market forces all by themselves are going to keep us from going up to that level, why waste the political capital, the legislative capital, the personal capital to put this in place? Because this has to be imposed somehow. If the market's doing it for us, we don't need to impose it on our own. Same reason why a wage floor will never be below W star, because the market keeps us from going down to that level. Okay? So let's say in this case we have a wage ceiling that happens to come in at 4. Such that we're down here. Now we have this condition where labor supply is less than labor demand. And now we have a labor shortage, right? So now there's going to be some black market activity. There's going to be some cheating, if you will, with wages and such. And end up having to pay some workers more than 4 in order to get them to show up in the market. Okay? So you can see then what has happened with worker surplus and employer surplus. We used to have worker surplus in this entire triangle here. Now it's this tiny little space here. Pathetic, right? And we used to have employer surplus in this large triangle here. Now it's a little triangle and a rectangle, and that's our employer surplus. And we have tiny worker surplus, and we have a honking deadweight loss. We can see that. Okay. In either case, when a wage is imposed, that is either a wage floor above W star, a wage ceiling below W star, it creates an inefficiency or friction in the market such that we no longer have the same amount of surplus for the economy as a whole, and we have some deadweight loss or some inefficiency because of some exogenous imposition in our production. Any question about any of that?
What would be like an example of like a wage, like for a wage
Perfect question.
floor we have minimum wage?
So we understand wage floors, right? Why a wage ceiling? Why would anyone want to limit the wages of workers? And have we ever actually seen that occur from a legislative or a political or contractual body within our economy?
The NCAA doesn't allow you to pay college
Well,
players.
that's a really good point. Dominic, will you close that door for us, please? We're getting some sound. So we have evidence of contracts that try to keep wages down in various professional sports so that ticket prices, etc., just don't go out of sight because of the inelasticity of demand for those marquee players, because they can require almost any wage. So we have a contract from their union that somehow suppresses that. That's a good example. An example from a government standpoint might be what happens if we have inflation, wage spiraling inflation, and it's out of control, and we want to put a lid on it, we want to cramp it down. Then the government, state or federal bodies, may come in and say a worker of this skill set can no longer be paid more than X. And X probably is going to be below the current wage, because remember, there's no reason to put it above the current wage, right? Well, what's an example of that? You guys probably are too young to remember this, but when President Nixon was the president and we had double-digit inflation, we had double-digit wage increases annually, that was a killer for the economy. We were in an arena we call stagflation, and stagflation is second only to depression in terms of its economic severity. And some would argue that stagflation might be worse than depression. I'm not sure I'm one of those, but I'm not a macroeconomist. So in this case, just for the sake of the nation, he came in and said wages are fixed at this level. And some of them had to come down, some of them simply couldn't rise any further. So that's an example of that. I think that FDR, Franklin Roosevelt, did the same thing at a point where the economy was growing so rapidly coming out of the Depression, and because of the war era and all the production for the war and such, we had the same kind of problem. So that would be an example of that. Okay? Let's look very briefly at what a labor quota looks like without any numbers. Okay, get rid of all of this and just see it very briefly, because there's something that goes on in the labor quota that probably isn't present in a wage floor or a wage ceiling. While I'm doing this, what creates a labor quota? What are some of the conditions that might create a labor quota? I think one of them might be, let's say that we have an economy that doesn't pay auto production workers very well, let's say. And we aren't employing very many of them, but there's lots of them around. Maybe we've shifted a lot of our auto production to Canada or to Japan or to Mexico, which is currently a concern, right? So the government might come in and say, Dominic, you are an auto manufacturer. You now have a quota, you must have X numbers of workers. And that might be, in this case, almost certainly is more than you currently have. Or maybe it's just the opposite case. We have a scenario in which, and this again was an issue within World War II, where so many of our young men primarily were shipped overseas to try to keep us safer here or to affect the agendas at hand. And domestic employers needed workers because of all this production for the war effort. We started bringing women into the workplace. We saw that and discussed that in our labor market module, the first module. And there were labor quotas. A firm couldn't have more than a certain number of workers. It was imposed because we needed to keep our available young men to ship them overseas to fight in the war effort. So there's lots of different possibilities there. But it sets up an unusual situation that's worth talking about. And we'll do it without numbers. By the way, notice that every time I've drawn something like this, I label W, I label L, I label labor supply, labor demand. If I had numbers and equations, I would label each one of my relevant intercepts in positive space. Oh, I don't know that I need to label it in negative space unless my equilibrium is in negative space, which it should not be. But I label everything in positive space, and I say W star equals some number, L star equals some number. I don't put in parentheses two numbers up here to represent that point. It's not that that'd be wrong algebraically, it's wrong with the convention of labor economics, and you've never seen me do it in one of the videos or one of the problem sets. So that said, this is our perfectly equilibrating market, and then for whatever reason, let's assume for a minute the labor quota is imposed out here, a labor quota. Well, we know employer surplus, we know worker surplus. But now, what do these look like now? If it's a labor quota and it's above the current L star, that's going to be suggesting that we want to have more workers in the marketplace. Okay, I can maybe live with that. So it's we want more workers to be demanded. I've got a mismatch that occurs because the firms are going to want to pay WD, right? But the workers are going to want to receive WS. Well, if the firms pay WS, where do they get the money to do it? There's probably some government credit, subsidy, etc. that helps them do that. Which in this case, if the intent was to cause more people to enter the market to work, then we wouldn't be thinking about this one, and we would see that now this becomes worker surplus, and we're still at employer surplus. Okay, so employer surplus got real big or real small, worker surplus got real big. Where is deadweight loss? Well, you might say it's this triangle right here, and that might be indicative of something, but without knowing what the government policy is, subsidy, credit, etc., who's paying for it, how it's being paid, how much it might be, we really don't know what deadweight loss is. So there's a piece of information that's missing here to really understand deadweight loss. But what we know, worker surplus got big, employer surplus got small, total surplus changed. And yes, total surplus changed by the size of this triangle right here, but I don't know that that's necessarily deadweight loss until I know some of the credit, subsidy, support mechanism that went into play to cause this to take place. I won't draw the other part, but I'll kind of talk through it. What if the quota was less than L star? Well, now it's easy. Now we see the deadweight loss. I guess I will draw, I want to erase the rest of this. If this was the quota and it was below, now we see deadweight loss very simply, don't we? Okay? And now we would see that we would have a big employer surplus and a small worker surplus, just the opposite. In part because this number of workers is going to be willing to work for a small wage. The firms would have been willing to pay them a much larger wage. And so my guess is this deadweight loss is going to be counteracted by some taxing policy to cause the firms not to unnecessarily profit because of this condition. Does that make sense? Okay, any questions about friction that I haven't dealt with in this so far? Okay, so let's go on to Dominic's favorite topic, elasticity. Which, Dominic, as it turns out, I think we can explain an awful lot about what happens in labor markets generally because of elasticity. We'll keep the same two equations we had. But I want to remember for a minute what our W star and L star were. Recall that W star was equal to 5 and L star was equal to 5. We're going to come back to those. So what does elasticity look like? Well, elasticity is a change, right? And elasticity, when we think about it, uses this kind of nu, or the Greek in, as the symbol, and it equals some percent change in labor given some percent change in wage. Okay? And we think of this as being own wage elasticity when both changes are for the same type of worker. But if it is some percent change in labor of worker I divided by some percent change in wage for worker J, I and J simply denoting that they're separate, different, then this may be a cross wage elasticity. One of the other things that we're going to want to have to keep in mind is how we interpret or explain or think about elasticity. And we think about it as in absolute value terms. In part because we want to use the exact same metrics and rules for demand elasticity, which results from a downward sloping demand curve, negatively sloped. So we're going to have a negative relationship or correlation. We want to use the exact same rules for labor supply elasticity, which is upward slope or positively correlated. We haven't talked much at all about labor supply elasticity in this course. It's not that it doesn't exist, it's just that it's not as relevant, and there's only so much we can pack into the weeks we have, right? I know you want more, I'm too lazy to do more. Or maybe not. Okay, so I can think about the type of elasticity by thinking about the value here. So I'm thinking about this, so when the absolute value of this elasticity is greater than, equal to, or less than 1. So the absolute value. Well, if this is demand elasticity, this own elasticity should be negative, right? We'll see that in a moment. Well, I want the absolute value of that. So I want to strip away the negative so that it makes it positive so I can use this rule. And we call this elastic. We call this inelastic. And we call this unit or unitary elastic. Okay, when it's equal to just straight on 1. Okay? Well, let's think about this for a minute. And let's think about how we would go ahead and model this. We'll use these equations. So we know that we've got W star at 5, L star at 5, and let's say that those are our initial conditions for us. And we're going to make a change in wage. We're going to impose some change in wage and see how it affects labor so we can have then a secondary condition so we can affect our equations. Because our equations for elasticity, simple elasticity is equal to L2 minus L1 divided by L1 divided by W2 minus W1 divided by W1. And if we times this by 100, you would easily see that that's a percent change. And we times that by 100, that's a percent change. And the reason we don't put the 100s is because they would cancel each other out. You may as well not even have them there. Okay? So this is going to give us some decimal equivalency. And if this is own wage elasticity, then we expect it to be, and it's demand elasticity, we expect it to be negative. So, and we're going to talk exclusively about demand elasticity here. Well, there's another equation to think about. It's called the midpoint equation, or the midpoint formula. And that's going to be equal to L2 minus L1 divided by L2 plus L1 divided by 2. And divided by W2 minus W1 divided by W2 plus W1 divided by 2. So the question is, when would we use one versus the other? Well, as it turns out, the midpoint formula does give us a slightly more accurate elasticity value. And that's most important if our elasticity appears to be close to unit elasticity. We want to know, is it really above or is it really below? Maybe we're going to bring out this equation, but more simply, if the change in wage is large, then the simple formula will not give you an accurate elasticity. It's too generalized. So if the change in wage is large, then I'm going to think that we would always use the midpoint formula. So we have to define, well, what is large? I'm going to say certainly if the change in wage is 10% or more, go to the midpoint formula, because that's a large change in wage. And if you don't think it is, because it's only 10 points, just tell me how you feel if I take away 10% of your income. And now, all of a sudden, you know it's large, right? Well, let's kind of see what elasticity looks like generally when we're thinking about it graphically. So if I have wage and labor, and my demand curve is vertical, this suggests that at any given wage, regardless of what the wage is, I want this number of workers. I'll just call it L prime. So there's no give at all here. Wage can move a tremendous amount. It can be very stretchy, and labor demand doesn't move at all. What's an example of that kind of worker, perhaps? Is that a construction worker?
No.
No, because there are so many substitutes. If I'm a landscaper, or if I'm a framer on a residential construction site, or if I'm hauling trash, or if I have good physical stamina, but maybe I'm a clerk at Walmart, I'm probably a relatively low-skilled worker and very substitutable. So if I demand anything more for my wage, going to replace me with somebody else. I'm done. So that's not this. Claire, what might this be?
Like a highly skilled surgeon.
Yeah, and on the videos I use brain surgeon, right? Because I'm pretty sure if you need a brain surgeon, a ditch digger won't do, right? If I need a brain surgeon, I don't want a stockbroker. They might both be highly skilled, maybe, maybe not. They might both be highly skilled, but if I need a brain surgeon, I need a brain surgeon. Without it, I'm dead, period, okay? Well, okay, we get that. So highly skilled, which means that we've got very large change in W creates no change in L. So large change in W, no change in L. This number is going to be very small. In fact, if it really is vertical, which is almost unheard of, right? If it really is vertical, this is going to be null. It'll be so small. Effectively
That's
zero.
perfectly inelastic?
Yeah, that would be perfectly inelastic, Don, if it was truly vertical, okay? Now I'm going to guess if this is my scenario and I need a brain surgeon, and the brain surgeon says, well, you know what? For $7 trillion, I'll operate on you. Even if I had it, my answer is probably no. Because I'd rather go ahead and die my peaceful death and leave my $7 trillion to my posterity. Okay? So this probably isn't really purely vertical, but it's darn near for a brain surgeon, right? Which is part of the reason the brain surgeon or any highly skilled individual can derive and require a relatively high income. Okay. You guys are working on that right now, right? In seeking a college degree, you're trying to signal to the labor market that you have invested in your skill sets so that you can create greater productivity, so you can create greater incomes. Otherwise, I'm pretty sure on a beautiful Wednesday night in the middle of summer, you'd be doing something else. And it is, it's beautiful outside, and we're here. Well, what's perfectly elastic look like? It's horizontal, which suggests that at this wage, we have an unlimited demand for this type of worker. Okay? But if we go up one iota, one tiny little bit in increase, we don't demand that at all. Now, you might say, if we go down one tiny little bit, we don't demand it either. That may not make logical sense. But if we increase this at all, no demand for this type of worker, because we know there's some other type of worker that's perfectly substitutable for this one. And I think in the consumer goods market, for me, this would be Coke and Pepsi. Frankly, I don't drink either of them. I'm a Diet Dr. Pepper guy. but if I drank one of them, I recognize they're both just brown, fizzy, colored water that's got a little bit of sugar or sort of something and some taste. And to me, they both taste the exact same thing. So if I drank one of those, the price of one went up, all of a sudden I don't drink that one, I drink the other one. Okay? So this is perfectly elastic, such that even a tiny % change in wage makes a huge difference in labor, such that now this is a very large value to a very small value, we are far greater than 1. And the issue here is substitutability. Okay? So let's think about what this market looks like over here that we identified earlier. We said it was a low wage market. Is it got an elasticity that is similar to that? Immediately, I'm not sure if it does. So I have an initial condition, and we'll say that W star is W1, L star is L1. Okay, our initial points. And let's go ahead and give ourselves a W2 and an L2. This all starts with a change in wage. So let's say in this case the wage changed by $1. So now we have, instead of 5, we have 6. So it went up by $1. Well, what is our L2? We're going to put this 6 in wage back into one of these equations to find what L2 is. Which equation am I going to use, Claire? Supply or demand?
Supply?
I'm actually going to use demand because we're talking exclusively tonight about labor demand elasticity, which also means to pay very close attention to any question on a test, because I'm talking about demand elasticity, you're going to use demand equations. That's a very common error that I see made, and it can be a critical error. The other common error I see made, by the way, is reversing the numerator and denominator. Wage does not belong in the numerator. Labor does not belong in the denominator. Labor is always in the numerator. Wage is always in the denominator. Always, always, always. Okay? So if I have then in demand, I've got LD is equal to 15 minus 2 times 6. 15 minus 12, I think is 3. So now I can set up my equation. I'm going to look at this. I'll do first a simple equation such that I've got 3 minus 5 divided by 5. And that's going to be over my new wage is 6 minus 5, my original wage, divided by 5. So I have negative 2 divided by 5 over 1 divided by 5. Now I'm kind of a simpleton. I don't like to do complex fractions. I like to break them up, or at least complex quotients for fractions. I like to break them up, but I know I can flip this and set it alongside the supernumerator. So negative 2 divided by 5 times 5 divided by 1. And you might say, well, wait, quickly, the 5 and the 5 cancel each other out, and that's true. I'm going to expand it out because it's not always going to be this simple. But this is going to give me negative 10 over 5, which I believe is negative 2. What would negative 2 give us in terms of the definition here for elasticity? Elastic or inelastic?
Inelastic.
I think, Dominic, it's actually going to give us elastic because we're going to put the,
Oh, that's
we're going
right.
to take the absolute value of this.
Sure.
So we want to think about the absolute value of negative 2, which is 2, and it's greater than 1, it's elastic. Well, now that makes sense to us because we said this is a low-income worker. Remember? $5 an hour.
Yeah.
Low-income worker. And low-income workers are certainly going to be elastic. Okay? So remember that this was, I'll give it over here, as negative 2. Let's go ahead and apply this to the midpoint formula to see just how inaccurate it was, because I have a 20% change in wage. That's certainly more than 10. I'm going to bet for a moment that it's still elastic, but that the elasticity quotient or value will be different. So I'm going to then say 3 minus 5 divided by 3 plus 5 divided by 2 divided by 6 minus 5 divided by 6 plus 5 divided by 2. So I've got negative 2 divided by, so 3 equals 5, 8 divided by 2 is 4. And that's all going to be divided by 1, divided by 6 plus 5 is 11 divided by 2, 5.5. I'll simplify this because of my own